Order that happens when there's an imbalance in the pulse. Atrial, atrioventricular. Um, I
Okay, have you ever seen the commercials? For example, atrial fibrillation,
Yeah.
ventricular, okay? And when we walk around now, a lot of buildings have the defibrillators, okay? Sometimes and I just learned this a couple of weeks ago, okay? I thought the implant for a pacemaker was the same thing as the defibrillator. Oh, no, it's not. Okay? Pacemaker deals with that SA node. Okay? The implanted defibrillator is dealing with these electrical impulses.
They have one though that's like that where they can put it
where they can do both.
It shocks them.
Depending upon what they may have wrong with the heart. So, this structure, because think about this, the average age for the U.S. now is what, in the 70s, okay? Take that, and if on average 65 to 75 heartbeats per minute for those I'm sorry, I can't do that kind of math, okay? And if it does it correctly all the time, you're doing great, okay? So this structure that we have and this cardiac muscle, all right, and because when the heart beats, it literally does a twist and comes back, is our spiral. Okay? Because that is, it's almost like it pushes up. Well, it does. Pushes up, twist, release, and comes back down for that heartbeat. So we call it the myocardial vortex because of this movement that it performs. When we look at what they term the fibrous skeleton, we're going to find collagenous fibers and elastic. Collagen fibers in the body as a whole, collagen is found pretty much everywhere, okay? Think about it being, because you know it's under the skin, all right? It's in the bone. It's the rebar for the concrete of the bone. All right, so they're actually very tough, very little give. Okay, elastic, not as tough, more give. Okay, so this structure that we have concentrated around the valves. Take a peek back at your valves. Hopefully you see one on the right and the left. And it looks like it's got all these little cords attached to it. Once again, these two that are here, they're giving us structural support for these valve openings and the ones that lead to the great vessels. All right? They're going to help anchor cardiomyocytes, cardiac muscle. All right? They act as electrical insulation between my atria and my ventricles. All right? And then we're finding they might help with refilling the heart with blood based on the elasticity of elastic fibers. So the structure is important to how the heart is going to function. have you ever known anybody with heart problems? What kind of stuff did they have? Michelle?
Similar, end up having a stent put in.
Okay, which would be in vessels,
Yeah.
okay, to help the blood flow because it probably got constricted in some way.
Yeah.
Anybody else? Okay.
People with heart conditions, don't they usually have to take like blood thinners?
They can actually have to take a lot of stuff.
Yeah.
Now, people who are on blood thinners is because the blood is, for some reason, thicker than what it should be. So being on a blood thinner is hopefully going to allow it to move through the heart easier, because one of the things about the heart beating, based upon its size, the amount of fluid that it deals with for every heartbeat, it's pretty considerable. All right? The easier that fluid can move through these structures, the less your heart has to work. All right? But they, you know, we have stuff for high blood pressure, low blood pressure. We have medications that will affect the actual heartbeat. There's tons that's out there for the heart now. So this structure that we look at now on your, you know how I made that piece of paper about structures to be familiar with and be able to identify? That's how I'm going to want you to be able to do that, okay? I want you to take that list that I've given you, and based on the structure, all these models that we have here, I want you to be able to identify those on a heart model, all right? Be familiar with them in a picture also. So I think on the list that I've given you, it's not like, I don't think I've given you everything to label, but the structure of the heart, when we look at anterior versus posterior, couple of things I want you to pay attention to. Definitely pay attention to our vena cavas. Definitely pay attention to our aorta. Pay attention to branching that comes off of it. Now, take a peek at this blood flow to the lungs and back to the heart. Okay, if my blood comes into the right side, from the right side, it's going to enter into this pulmonary trunk that's on the back of the heart. Okay? Now, note they go to both the left and the right. All right? Once the blood circulates in the lungs and begins to return to the heart, note that I have left and right because it's coming from left and right lobes of the lungs, but it only comes to the left side. All right? So just little things to kind of note. Something else. My blood vessels that are feeding the heart tissue, okay? The blood supply to the heart is very unique because we tend to think, okay, well, this is my heart. It pumps my blood, sends it to everywhere in my body. The heart is tissue also. So therefore, it needs a blood supply. So what we find is we find our coronary circulation. Well, I had a coronary. Have you ever heard somebody say that? No? Okay. If you hear somebody say, I had a coronary, they had a heart attack. Because what they're referring to is my coronary circulation that feeds the heart, and somewhere the blood stopped. And that area of the heart lost its function. So my blood circulation, note that I have this coronary sulcus. Does anybody remember the definition of a sulcus? Like a groove, a little depression that exists. Goes all the way around between the atria and the ventricles. Okay? And because I have 4, think about this, okay? Atria, ventricles, left, right. It looks like it takes a pathway to each one, front and back. Is everybody following me? For the blood supply. So it looks like I've got these vessels, arteries and veins, that go all the way around between atria and ventricles. And then it looks like I get blood supply down following these sides. Okay? And it looks like we got 4. So, I had a triple bypass. Anybody have any idea what that means? First of all, what happens in bypass surgery? Gabrielle?
Isn't like when they take veins from other parts of your body and replace it?
They'll take veins, usually from your calf.
Yeah.
Okay, they'll take vessels, come up to your heart, and connect them to bypass the part that's shut down. Does that make sense? So I had a triple bypass. How many areas? If it looks like I've got 4, they had to do this to 3 areas of my heart. I had a double bypass. Looks like they had to do it to 2. I had a quadruple. Every single one of them. But if you survive the surgery, wow, life has changed for that person. Y'all ever known people who had bypasses?
Yeah, my granddad had it when I was like 8 years old. And I can remember they told him not to drive or something, and he drove, and he came home, and his legs started to split open where they had
removed it.
Yeah.
Yeah. And the advances that they've made in that surgery are amazing. And what they have done, because in this structure that's present, in that heart where blood flow is cut off, even though the cells in that area are not going to go back to working, what will happen is by creating the bypass, they're supplying blood to the other cells that are working, and they become more efficient. And that person's quality of life improves drastically if they survive the surgery. That's the big kicker, okay? So